we don't believe you can do it. That's it.
Y'all didn't do it. They failed. 8 miles.
We did do
8
it.
miles.
That's the whole point.
They were wrong.
Here on Earth.
Now you're going to tell us what's happening at the center of the sun?
Now,
93 million miles away?
Wrong about? What were we wrong about, Rakia? What about the 8 miles was wrong?
Well, the study that I read, that every time they went down and took core samples and said it's going to be this, they brought up the core sample and it wasn't.
No, there's no such article.
Somebody was wrong. I don't know if it's true.
Maybe
or not,
that was a false argument.
I believe. Look, I don't. This always comes as a shock to you guys, but science gets things wrong a lot. In fact, that's the nature of science: is to get things wrong.
That's what we're trying to tell you.
That's what we're telling you. You don't know what's at the center of the sun.
So when you hold that, so listen. Let me finish. So of course, we don't know for sure. We're telling you the best ideas we have so far. So when you guys point out that science got something wrong, you're not telling us anything we don't know. It's the strength of science. It's willing to be wrong because it's willing to correct itself.
You're basing everything you know.
Yeah, you're conceding, and they're not showing you anything that's practical.
No, we're not basing everything we know on what the sun is. Don't be absurd. That's ridiculous.
Can we come back down to Earth now, because you've moved away to the sky, but conventionally away from the mountain?
No, y'all brought up the sun.
You all did that, and
you brought up the sun.
Relax.
It was only to reference Montreal's point.
We can stay on the sun.
This is how it happens.
We can stay on the sun. It's
y'all
fine.
begged SC to talk about the mountain, and as soon as he started talking about the mountain, the other guy brought up the sun.
No.
Yeah, that's exactly what happened.
Yeah,
he talked about things shrinking and grim.
Yeah,
no.
And that guy brought up
I can't talk.
Sheeple, this is not worth it. This is not worth it, Sheeple. Sheeple, this is not worth an argument. Like, just who cares? So, what do you guys want to talk about?
SC was talking about the mountain, right? That's what SC. Y'all begged him to do that. He was doing that.
Pick a
he
topic.
Mentioned something about angular size change, and y'all brought up the sun.
Fine, it's not worth fighting about. What do you want to talk about?
Angular size change.
So do you guys admit that you were wrong about the sun? Let's see some humility. Do you guys admit?
What do you want to fight about? What do you want to talk about?
I want to say the only reason the sun was brought up was to challenge the blanket statement about everything shrinking in angular size. That's what it was about. Rocket's trying to make the point.
Why is that important?
You said we diverted. Your exact point was we diverted. We did not. Y'all did.
No, he asked how we know how far away.
You diverted.
That's all I need to know. It's all right.
Beach. Can objects in the distance be obstructed by atmospheric conditions between you and that object?
No, you diverted first.
M. Scott Beach. Can objects in the distance
answer his question?
Can objects in the distance be
like you answered mine, Montreal?
Oh my God.
Go ahead.
Come on, Scott. I answered you.
Oh my God.
Don't be disingenuous.
No, you never gave me an answer. Not one time, but it doesn't matter. Go ahead, Ricky.
M. Scott Beach. Can you hear me?
Relax, dude. If you're going to yell at me, I'm not going to respond.
Bro, I said your name and asked the question 3 times, and you're talking to S.E. Montreal.
Okay, I can't. Well, I was talking to him first. I can't hear your question. Go ahead.
Can objects in the distance, let's say a mountain, be obstructed by atmospheric conditions in between that mountain and a viewer?
Sure.
Anything else y'all want to talk about?
What about when it's clear? Like,
yeah, I mean, I guess the caveat to that would be there is telltale signs when the atmosphere is obstructing objects in the distance.
Unclear.
Yeah, like you can't see.
And this is what it would look like on a flat Earth.
You already know this.
Like that video with your boat that's being just refracted into oblivion.
When you zoom
in, it has no defined edges, no defined shapes.
But when you zoom
it's very obvious at that point that there's major distortions going on, right?
Yeah, but look at the beginning of the video. It's a beautiful day. It's clear. Why are you talking?
Why are you pretending like you don't understand
the boat is not clear. You don't have this perfectly defined edge that you do.
And the boat is only 4 miles away or so. You see how unclear it gets? You see how unclear it gets over 4 miles?
It doesn't mean that there's not refractive effects going on because there's a big variation in the temperature in the air.
Yeah,
of course it doesn't mean that. No one's saying that.
Guys, I spent just a few hours on the beach, and I have, on my video there, I have proof of a sea-doo coming in and out of view due to the not the curve due to atmospheric refraction. Just look at my video.
Yeah, it's absolutely possible, but like I said, there are telltale signs when the atmosphere is doing that, which is not defined edges, no defined shapes, right?
No,
very blurry imaging, where you can barely make it out, where you don't have well-defined image, right? Which is different than a crystal clear day with no refraction, where all lines are true to straightness, where everything is clear and in focus. It's like telling me I don't know the difference between an in focus or out of focus picture.
As soon as you said crystal clear day with no refraction, you lose.
Why is that?
Because there's no such thing.
No, there's pictures. There's lots of pictures of that.
Well, maybe. I'll backtrack a little. No, there's no such thing as that.
Backtrack a little.
No, I'm not.
Of course there is.
No refraction.
There's going to be a small amount of refraction, probably still, sure.
Prove that.
So
yeah, but
there's not necessarily going to be a small. There's going to be no refraction someday. I can't tell you which days they are. I can't tell the difference between those and very little fraction, but I'm sure there's going to be some with no refraction.
M. Scott Veach. Yeah. 14,000 foot mountain. Could the mountain be clear and the bottom be distorted?
Not through atmospheric effects alone, unlikely. It's possible, but it's unlikely.
What else would it be?
Well, it'd be obstruction from the earth.
Okay, so obstruction from the earth is one thing. What else? Let's say you're 180 miles away.
So
obstruction from the earth in your model would be one. Okay, obstruction of the earth.
Obstruction from some other object.
Okay.
Obstruction from some other object.
I'm already giving you the 180 mile an hour picture.
Yeah.
I've already given
I don't know
it
what else.
Scott, look at the picture. Tell me if there's distortion in it.
What picture?
Let him Scott Beach keep answering. Hang on. Earth curve.
No, just so he knows
what.
Before you take him down a rabbit hole.
Yeah.
You know, that's what we're looking at.
That does not look like distortion to me. That does not look like any distortion to me. That looks like a clean picture.
Here's another picture. Look how defined those containers are.
That looks very clearly like it's being obstructed by the Earth's horizon. I mean, it's exactly what it looks like. Let me see this other one. Yeah, again, these pictures that we get are really good, guys. They are compelling. I don't know why you guys just blow them off. Like,
okay, so can I ask you something about that picture? The 1201? The dark line at the base of where you can see where the mountain meets that dark line. What's that dark line? What is that? Is that trees? Another mountain? Is that water? What is that?
All right.
M. Scott Veach.
God, just so you know what trees he's talking about, here's the mountain scaled with the picture. Here you go.
Hello. He doesn't need
trees aren't a factor, clearly.
I'm trying to find the one you're talking about.
1201.
So is this a picture? I can't really see the times. I heard you, Rocky. I can't see the times on my interface, so I'm trying to find them.
Sheeple's Phoenix posted it.
See? So there's the one overlaid. So the trees aren't a factor, Scott.
Why are you talking, Sheeple?
Big difference.
Okay, so it's the one where I can see the top of a mountain in the very far distance and the ocean in front of it, right?
So where the white mountain, it's snow capped or whatever. You see the top of the mountain, and you go down to that black where the dark line is. It looks like trees to me. What is that?
The dark line.
It goes all the way where the white meets the dark part of the mountain. It goes all the way across the mountain, bottom of the mountain. You can
where?
Oh my goodness!
It's this one I just posted, right? I just double checked.
Yeah, that's if you open up in a browser and expand it up, it's not trees; it's just a shadow of some sort. So it's probably actually a different.
Now y'all are using a different. Now y'all are using. Okay, M. Scott.
Those are the mountains. That's actually land.
No, the one M. Scott posted.
Hold on.
Hang on. I'm talking to M. Scott.
I know. I added what Veach put down. Veach put the 130.
Why is this so hard?
All right.
Veach put the.
Go ahead, David. Nobody believes you, but go ahead.
What does this have to do with belief? I'm not asking you to believe. I'm asking M. Scott a question. He won't answer. Y'all won't let him.
Well, what's the question? You haven't asked it. You haven't asked.
Where the white mountain, right? Where the mountain that you can see and it's got snow on it meets that dark area. What is the dark area?
That's land. Those are mountains.
Why is Zanuck cutting in?
I don't think it's land. If I understand what you're referring to, if you look at the picture that I reposted.
Yeah,
hold on, Zanuck.
I'm looking at the one.
If you're talking about the line. Okay. So the line between where the mountain and the water is, I don't see that as a dark line. Now, I maybe need to expand it or blow it up or something, but it just looks like blue to me.
That's land, beach. That's a shoreline.
Scott, on the last image I posted, Scott. That's
Okay,
what
it's
he's
dark.
talking about.
It's a darker blue.
I've driven that distance many times back and forth from that area.
Okay, whatever it is. Okay, let's just say it's
just
land.
where, and it's just where they cropped the original image and overlaid it. That's the sea in front of the original image, or the land in front of the original image from distance. That's all it is.
Okay.
So that's land.
So that blue on the picture you posted, that blue at the bottom there, that's the sea, right?
Yeah, that's basically he's taken a cut from the picture you posted, which is with Mount Rainier.
So where is the dark line that he's referring to? Because there's no dark line there. That is the
dark line he's referring to.
But it's no darker than the rest of the sea.
Very straight is land.
No. But if you look at the overlay on my picture, you can see where they've overlaid your image on top of this one, and part of it is the dark line of the sea underneath the mountain, which is why it doesn't extend all the way across.
Scott Beach, do you want to walk through this with me or not?
This is the one we posted before.
Sure.
Why are 5 people cutting in then?
All right, let Scott and Rocky talk. Let Scott and Rocky talk. Yeah, let him go.
Your picture that you posted, 1204, Scott Beach. Look at that one. You see, we have water. We have water, and then we have like a little piece of land. Then it looks like we have more water. It's blue. Then we have a distinct color change. It looks a little darker, whether that's water or...
That's the land. No, that's the land.
Why is Zanuck?
Because no one seems to know.
Zanuck, you're not Scott. Zanuck, let Scott talk.
It doesn't even matter what it is.
Yeah.
It doesn't matter what it is.
Okay, so what about it? So what about it?
Area, okay, the darker area that meets the mountain. All right? You see it? Where that top part of the dark area meets...
I have to tell you guys, if it wasn't for you guys calling it a darker area, I would never say this. But I sort of know what you mean. I'm looking at it. I think what you're talking about. It just doesn't look that much darker to me. But I think I do.
Wherever the water or land meets the bottom of the white part of the mountain, wherever
that's what I'm looking at.
What's that height? What's that height? What's that height? Does anybody know?
That sea level.
You don't even know if that's sea or not. What are you talking about?
Up there.
I think that's the horizon. I think that's ocean. Zanuck.
With the island, which is about, I don't know, 500 feet.
Hey, Zanuck.
You're not Scott.
What's going on here, Zanuck?
So we can have this conversation, please.
Do you just want to... Do you need attention, Zach? Do you want to talk? It's okay if you do.
I'd say, does anybody know, Scott?
I know, but you know what, though? You just got to have some self-discipline and take your turns. It's okay.
Okay,
I mean, you can talk if you want. I don't need to talk. I don't care that much.
Does anyone know the height of that, whatever it is, water or tree line or land?
I think it's water and it's sea level. I think it's water and sea level.
Yeah, but we don't want to think. We want to know because there's probably a point to that question.
What I asked. Does anyone know?
You're never going to know it. You're never going to know for sure.
That's why I was running in because I've driven that millions of times, and it's a landmass. That you have a bay there, the bay ends, and you have land, and there's hills, and there's mountains.
You think Scott does not know that?
I mean,
why is he saying?
I mean, I don't understand what you're saying. Because we're looking at different things potentially. The white stuff, the mountain is obviously land.
Reiki made it very clear. The blue line,
obviously,
it's not darker in my eyes.
Holy shit!
Let me go with Zanuck since he goes there.
Reiki,
what do you think it is?
I know what it is. It's a landmass because you have water.
And how tall does that landmass have trees on it?
Yes, trees and hills.
How tall is the tippity top of those trees? What elevation is it?
Well, you're looking at some that are actually hidden beyond the actual shoreline there. That actual shoreline, you have the close-up picture is that's actually not the same area, but it's roughly about 300 to 400 feet or some of those hills.
So you got 300 or 400 foot, let's say, to the top of the trees. And how tall is the observer in this picture?
You're looking at a pretty wide area here across.
Yeah, it looks like it goes straight across, almost horizontal. So you'd say that's the same elevation across there?
No, as you can see, there's different elevations along that.
Yeah, but where the mountain is, it's pretty clear, distinct line, right?
If you look at the zoom in, Veach posted. He has the best picture of what you're talking about, I think.
Yeah, I got it. I'm looking at it. Yeah.
Yeah, and so there's the blue that, like you called it perfectly. There's the water in front of you. There's a little teeny landmass in the middle of this bay, and there's water beyond it, and then you hit the edge of the shore.
Right.
And at that shore, you'll have trees and hills for another 50 miles or so till you get to Seattle.
So those trees and hills right there, how far are they away from the viewer?
There's actually, I think somebody posted, Foolish posted actually a map that actually shows that arrow from the observation to that.
That's my post.
So about how far?
People posted it then. Sorry.
Viewers 30 foot. About how far away?
Clear.
Yeah, about how far?
I think so. If what you're, and I think Ryris just put a close above it to show that there's a hill and some mountains there.
Yeah, about how far? How many miles?
Go look on the freaking map.
No one wants to talk about this, right?
No, look at the map. You can see it.
Yeah, this is what y'all are posting as proof. Y'all don't know anything about it.
See, look at the bay.
Okay, let me make my point, and let me make it real clear without anybody interrupting. If you don't know how far those mountains or trees or water is from the viewer, and you don't know the height, then how in the hell do you know what it's blocking or not? Because hang on without interruption, if the viewer is 30 feet and that mountain, trees, hills, whatever it is higher, then it's going to be obstructing that mountain in the distance. Especially if it's a lot closer to the viewer than the mountain is.
That's 60 miles away. So if you have a 300-foot mountain 60 miles away, go do the angular math. Go do the trigonometry and figure out what that would obscure behind it. It doesn't make sense. And not to mention that the mountain that you see angularly does not stack up to being 300 feet or 400 feet high.
Does anyone see my point?
It's also lower than
it goes down.
You're not letting me finish. You're letting me finish.
You're not answering any of my questions.
I am answering. You think I know you're going with this. I do know.
Well,
you want to know if that.
Do you agree or disagree?
I know what you're saying. I agree with.
Do you agree or disagree?
It's not a matter of agreement, Racky. It's a matter of knowing what you're saying. You're saying that if there was an object that is in the distance, that is a certain height, it will obscure things beyond it. That's what you're saying. But the point is, we know how high it is.
How high? How high is it?
300 feet, 300 to 500 feet for all those.
How high is the viewer?
30 feet in that one picture, the close-up picture.
So it's 60 miles away from the viewer or 100 miles away from the viewer?
So it's 60, well, you're looking at a curved coastline, so it's going to vary in distance. But the point is, Racky, just stop for a second so I don't have to yell. The point is that the object in the distance at 60 miles is smaller angularly, right, as it goes farther away, as you get farther away from it. And that's called the angular size change, right, the perspective. And it's not as large as it should be in your field of view based on its height. Why? Because there's Earth curve. Otherwise, why wouldn't we see it taller than we do? We don't. It's flatter than we would see it because of Earth curve. Just like the mountain is missing 12,000 feet of the mountain. Racky, we're not talking a little bit here. We're talking 12,000 feet of that mountain's missing. 12,000 out of 14,400.
12,000 feet now? Sheeple said like 2,000 yesterday.
No, 12,000 feet.
Huh.
The picture I showed you, 12,000 feet is missing.
The whole
2,000 feet left.
Oh, there's 2,000 feet left of a 14,000 foot mountain.
In fact, we shouldn't see any of it if there wasn't for refraction.
12,000 feet missing.
Yes.
We were giving you 10,000 just to be generous.
I never heard any of that. You kept saying 2, so.
No, 2,000 feet is left to see.
Left, yeah.
Yeah.
Anyway, I posted the link. If you don't see it, you don't have the link. You don't have the information you want. It's all in there. So, yeah. Welcome to Globe Earth.
Yeah.
But you did say, I just want to make sure you said we shouldn't see any of it but refraction. That was the answer, right?
Well,
no.
That wasn't quite the answer, but all right.
I'm pretty sure that's what he said, though, at the end.
No. No one brings in refraction. Rocky had tried to bring in refraction to save his
ass. Did he not just say that?
0.04.
All right, go ahead. Why should we not see the bottom 12,000 feet of that mountain?
No, I'm asking one question. Beach, did you not just say you shouldn't see any of it, but that's refraction?
Correct. We have 0.04 degrees of refraction that brings up that much mountain.
0.04 is like 12,000 feet of that mountain. Yeah.
Actually, 0.03 degrees. Sorry. 0.03 degrees of refraction.
But I mean, how do we know that mountain is actually there? Are you sure that's not mountain that's just been loomed up over the curvature?
Oh, goodness gracious!
Where'd the rest of it go?
Could be a hologram. Could be a hologram.
Lift it up, right, like a city does, and
Always moving the goalpost. Can't look at the sky, so we look at the mountain. Oh, can't look at the mountain because it's
is
distortion.
it physically there, or is it really hidden behind the curve?
All right, Joel Osteen, calm down.
It's physically there.
Okay, before I leave, I just want to say that we can all agree that, science is a method, like dance is a method of movement. And I mean, I think we should all just, dance.
Okay. Science is about repeating and testing, and this is what we've done. With these observations, we've proven that this is what's been done. We know angular size change, all the rest of it. I already posted what it should look like on a flat Earth.
I think Rocky is
getting away from the fact that the mountain is missing. Stop trying to use trees that are lower than the height of the piece missing in the mountain. It can't save you. And stop trying to use a small amount of refraction to bring back 12,000 feet.
Well, do you think a straight line of sight, like a straight line to an object far enough away that the atmosphere could cause it to be manipulated bottom up?
Yeah, we've done that. It's called the Sahelion. Or what was that mountain called? Sahelion? Am I saying it right?
So was the top of the mountain distorted at all, or was it just the bottom being?
Mr. Reality, this mountain is massive. It's not small. Okay?
The plumb bob got pulled over towards the mountain because it's a big ass mountain.
So look at the image I just posted. Look at the image. Look at the image I posted of the moon. Look at how the atmosphere.
We're not talking about the moon. We're talking about ground observation.
Massive, isn't it, though? But it's massive.
Don't look at the sky. Remember?
Yeah. Ground observations are worse, especially over water.
Oh, now ground observations don't work.
Well, yeah, they are. It's more dense than way up in the air, right? So if it was flat and a line of sight, man, you'd have so much distortion going on.
Does it look like those images are distorted?
Yes.
What image?
Can you not make out the mountain features?
Yeah, you can make out that it's a mountain, but it's real hazy and blurry and distorted.
Right. So you can match those features to the mountain itself, right?
You can't even tell if there's a city right there because it's so distorted.
Hey, Mr. Reality, where did that picture come from?
That picture was said to come from 240 miles in altitude, and it's supposed to be way above the Earth's surface before setting, so it's not even near the horizon, supposedly.
What's it taken with? A telescope?
Probably a Nikon. It's usually what they use, like a 500 millimeter or some sort of. If you look at the lenses they have, the largest one I've seen looks like it's like an 800 millimeter. Who knows? They probably have.
Well, can you find the source of it before we discuss it? Like, we've found the source of these images, so
I got it from NASA's website. I don't know. You'd have to. It was just a link to them. It's called there's videos. They have video of it, and I just thought this was probably the clearest one they had.
Did they also have a description of why it happens?
Yeah, they said it was the atmosphere. Having to look through the atmosphere and the gradient, I guess whatever it is, it's thicker at the bottom. Of course, they didn't say that. I'm saying that part.
Inconclusive. Fantastic.
If you're gonna deny what NASA says, shouldn't
any of the moon missing?
Done your research or what?
What?
Wouldn't it be funny if that's the way we saw the moon?
Think about it. If those astronauts could film, right, the moon as they slowly go closer to the Earth's surface, how much more compression or distortion or whatever you want to call it would they actually see? Would it become almost completely flat at the bottom? What would happen?
Shouldn't you have done?
Yeah,
we don't even know. We don't even know if this is cropped correctly. This could just be shrunken from the vertical. I mean, this is 546 by 267. Do you think NASA uses that ratio?
What ratio?
How much you know about your mountain posts?
It would be nice to know what that is rather than just seeing the picture.
Yeah, I think it's called moon set or moon setting ISS. I think that's
moon setting ISS. Okay, thanks.
Google that. I think, and then hit the videos. I think it should be linked straight to NASA's. The video is really cool. I made a GIF where I just fast forwarded it, and you can see it turn into that shape. When you make it fast, because it takes a long time.
Next time, leave with that.
What's that?
Next time, lead with that.
Lead with what?
What is this
description of how to find
thing?
We could have had it by we talking to you, but now the moment's passed.
Oh, okay. Well, I mean, I'm not trying to trick y'all or anything. I mean,
Did you take the screen? Did you take a screenshot from the video?
That particular picture is a picture. The video, the video isn't as clear as that picture. That's why
I found the video.
The video's cool though, and some of the videos are sideways, you know. So you can put it in iMovie or whatever, some type of software, and flip it to get it correct, and then you get a better image. But you can see a lot of the videos they show in these pictures, it's way above the horizon. And when it gets to the horizon, all of a sudden it starts to, you know, the land blocks the bottom. But notice right when it starts to kiss the horizon, it's pretty squished. I mean, almost flat. And then the top's not really even distorted as much.
Yeah, I'm looking at it. It looks like an egg.
I got a question for you. Is there any of the image missing? Is there any of that moon that is missing?
Any of it missing? Only when it really hits the land, then it starts to miss. But no, you can actually. It's cool because you can still see the details pretty good, like the shadowing and stuff. It compresses up into itself. It looks like around 300 miles according to what size they say the moon is. It looks like it kind of.
A little bit.
Zenit, look at that. Check out that video I posted.
Rykia posted a nice inferior mirage, too, of the sun. What's the problem?
Yeah, so it's kind of.
Do you see? Are you watching it, people?
I'm going to know. It doesn't really. It's kind of false equivalent. We're not talking about the sky. We're talking about a very clear, crystal crisp mountain.
Go to 119.
Yeah, but I think Rakia's point is how much more dense this atmospheric distortion could happen near the Earth's surface. Because isn't it more dense?
Why?
Right, but there's a band of refraction which the mountain is well below and out of. So where did it go?
Why would it be more dense towards the surface? I wonder.
I bet you.
There's a reason. There's a reason for that. Why? Why is that?
You know, some people believe it's gravity. Some people believe it's.
Some people believe that there's way more atmosphere that the sun is going through when it's lower. But yeah.
What?
Magic.
Well, the interesting thing, Titan has more atmosphere than we do. It's got a heavier atmosphere.
I just want to say thank you because Mr. Reality, because I've never seen the moon set from the ISS before, so that was really freaking phenomenal. I've never seen that before.
It's really cool. Yeah, definitely.
Pretty dope.
Really cool.
Yeah.
Well, there's some other cool ones you can do, like the hexagon window. You know, the hexagon when it's looking towards the horizon. I've tried to find one single picture from the cupola window, which is a hexagon. Just one that has the true angles of a hexagon, that, you know what I mean, and show the horizon, which I've never ever seen. Every time I see it, they always use a wide angle lens, which bends the, you know what I mean? It will change the angles and start to make the window look almost round. Like a lot of the times they do make it look round because they're using that real expensive wide angle fisheye. Looks like a 6.6 or something millimeter. Or 6 millimeter. I think that's what it is. That's
Isn't it pointing straight down at Earth, though?
Yeah, yeah.
So how's it going to shoot the horizon?
Well, with the wide angle lens, it still captures it. It's wrapped around the 6 millimeter lens. You'll see the astronaut holding it, and he'll seal himself up in that black material, and he'll black out, you know, where he's at, and just the little lens is sticking out. And that's how he gets those globe-looking images out of the cupola window, where it looks like the whole world's underneath him.
What the fuck?
You know what I'm talking about, right?
Globe-looking images.
Yeah, where it looks like the whole, like he's capturing the whole globe, but really
Why does it look like he's capturing the whole globe?
That's from the ISS as well.
This is what I'm talking about. This window right here that I'm posting is actually a hexagon. All the frames lose their degree due to the Nikon lens. And there's an image of him taking these pictures with this particular lens. It's like $60,000, and it just makes it wraps the horizon. It wraps it all the way around. Let me show you. Here it is.